6162 using the calculator, very specifically using the calculator to find the area. Oh, I mean probability. Alright, so instead of using the table like the book goes through in great detail, I'm just going to have us use the calculator. So, when you're given a picture like we have down here, right, we have a start, which is our leftmost value. We have our finish, which is our rightmost value. And we're trying to figure out the area. Or they might be asking, what's the probability? Remember, we can ask it both ways because area and probability are the same thing for what we're doing with the normal curve. Now, we're going to use the command on the calculator, normcdf. We're never going to use normpdf because we're never going to look for one specific value. We're always going to look for a range, an area, using it. Now, the syntax, the instructions that you need to use for the calculator are a starting value, a finishing value, the mean of your set, and the standard deviation. Now, you notice I intentionally did not label my mean or my standard deviation on this graph. That's because I used the variable z, meaning this is a standardized normal graph. So mu is equal to 0 and sigma is equal to 1. Alright, so I'm going to go to the calculator. I'm now going to get this area. I'm going to use normcdf as the command. So here's the calculator. I'm going to go to clear screen. I'm going to go to second vars to bring up distributions. normcdf is the second one I want. Go to it, hit enter, and now I just have to follow the syntax. Start, finish, mean, sigma. My start is negative 1.29, my finish is positive 2.1, my mean will be 0, my standard deviation will be 1. So that's negative 1.29, comma, 2.1, comma, 0, comma, 1. Close parentheses, hit enter, and that's how much area is found. Now, you got to be careful with the rounding on this one. Read very carefully. They're going to want 3 or 4 decimals, and so you're going to have to round it up from there, and it should match fine. Occasionally, you might get something that's more accurate than what the table is giving, but we'll deal with that as we have them. All right, so what's the area equal to? Well, the area is equal to, in other words, normcdf spits out a probability, and it's equal to 88.36%, which was the same thing as 0.8836. Now, a lot of what we're doing is going to look like this, where they don't give you a start, but they give you a finish, and they're asking for all of the area. So what value do you think we start at? So some of your calculators are going to have in it negative infinity, because that's the far leftmost point that you're going to have. When it's standard normal, I just have to use a number that's really far back there. So I'm going to use norm CDF again. My start for this one, instead of hunting for the infinity sign on the calculator, I'm going to use negative 100 or negative 1,000, just something that's big enough. I'm ending at 1.93, and it's standard normal, so mu is equal to 0, sigma is equal to 1. Right, plugging that into my handy dandy calculator. Second distribution, norm CDF, negative 100, comma, 1.93, comma, 0, comma, 1, close parentheses, hit enter. There's my area, 97%. Now, looking more at 6.2 as opposed to 6.1, here's more of an applied problem. What happens when it's not standard normal and you have a known mean and sigma? And we're trying to find the area. Let's just go to the right this time. How much area is there? Well, where do we start counting? We start at 80. Where do we stop counting? Well, positive infinity, but again, I don't want to hunt for that. Just use a really big number. So, on my calculator, clearing it out, norm CDF. Alright, I'm starting at 80. I'm going to, I don't know, how's 10,000 sound, right? And then our mean was 100, and our standard deviation was 15. Oh, look, that's the area. And that's all you need to do to get the area. Reiterating, normcdf spits out an area, it spits out a probability. We'll do something else on the next video to get our starts and finishes.